Hello everyone, welcome to all in YourPedia Education. My name is Manish Singh and today I am going to discuss with you one descriptive question for upcoming examiner of patent and design exam. So if you have filled your form, so you need to start your preparation from today onwards, correct? Because the time between mains, pre and mains is very less and that time is not enough for the preparation of conventional exam. So you need to start your preparation from today, correct? So let's see, whenever you appear in the final descriptive paper, so how to proceed, how to solve the problem, yes or no? Descriptive question कैसे solve किया जाता है and what are the things we need to incorporate it into the solution, it is necessary, correct? Because if you write the solution in a proper manner and if you give all the important details what we need to write in the for a given question, then you will get the final मैक्सिमम मार्क्स, yes or no? तो मैक्सिमम मार्क्स के लिए आपको क्या करना पड़ेगा, ईच एंड एवरी इंफॉर्मेशन को आपको प्रॉपर लिखना पड़ेगा. इज इट क्लियर? सो लेट्स सी, here I am taking one question from strength of material, and if I talk about more precisely, then this question belongs to combined synthesis chapter. So let's see how to solve this question. So you can see here, in this question what we have, the state of stress at a point in a structural component of elastic material are given as follows. So whenever you solve this kind of problems, so especially in strength of material when it is subjected to multiple stresses, correct, and you need to apply combined stresses concept or a Mohr circle concepts. So the first step is to write a state of stress, yes or no? So how to write a state of stress, you can see here. So you can see the state of stress of a point of in a structural component of elastic material are given as follows: a normal tensile stress of 100 megapascal and shearing stress of 25 megapascal. So let's say this is sigma x axis in which we have 100 megapascal stress, yes or no? 100 megapascal stress, and along with this in this plane we have a shear stress also, which is tau xy and its value is 25 megapascal. It is already given here. And now on one plane a normal compressive stress of 50 megapascal and complementary shearing stress of 25 megapascal on the second plane, which is orthogonal to the previous one. So in this plane we have, let's say this is sigma y, and this stress is nothing but this is minus 50 megapascal. In the y direction, in a y plane we have compressive stress with a magnitude 50 megapascal and it also has complementary shear stress, yes or no? So can I represent state of stress like this, yes or no? State of stress like this, state of stress like this, is it clear? This is sigma x, this is sigma y and this is tau xy, yes or no? So this is the state of stress which is given in the question. Now, and you can see orthogonal to the first plane and no stress on the third plane. Stress in the third plane means xz is equal to 0 and similarly tau xz is equal to 0 and tau yz is equal to 0. Correct? According to the question these informations are given. Correct? So determine, अब आपको क्या पता करना है, the maximum normal stress at a maximum shear stress plane, maximum normal stress at a maximum shear stress plane and the position of that plane on which they act. It means this is given data, which is already given in the question. So you should write like this, and after that you need to write what we need to find. Actually I am writing like this, but you write in a proper manner in a paper, correct? So find 2. So what we need to determine first, you can see the value of maximum normal stress sigma max at tau max plane, Is it clear? We need to calculate sigma max, maximum normal stress at maximum shear stress plane, and along with this we also need to find out theta s, the plane of maximum shear stress plane, because in that plane we have we need to determine maximum normal stress. And the second one you can see here, the maximum shearing stress at a plane of 0 normal stress. So you need to calculate tau max at 0 normal stress plane, 0 normal stress plane, correct. You need to find out this, and along with this you also need to find out that plane. So let's say that plane is psi. So these four information we need to determine from this question, yes or no. So these are the information which already given in the question. Okay, so let's see, after making state of stress, first we need to draw its Mohr circle, because without Mohr circle it is very difficult to determine those answers, yes or no. So how to draw Mohr circle? So first we need to write assumptions used in the Mohr circle, correct. जब भी आपको कुछ इस तरीके का यूज करना हो, इक्वेशंस या कोई मेथड यूज करना है, then you must write what are the assumptions used for using that method, yes or no. So if I talk about assumptions, so obviously here we have three assumptions. First one, along this axis we have sigma axis, and here we have minus sigma, and here we have plus tau, and here we have negative tau. So this is our first assumptions. Second assumptions you can see here, that is theta is represented by 2 theta in the Mohr circle. Theta is represented by 2 theta in the Mohr circle, and anti-clockwise theta will be taken as positive, and clockwise theta will be taken as negative. Is it clear? And next one you can see, third assumption, that is very important, and most of the students are confused how to represent shear stresses, which shear stress will be taken as positive and which shear stress will be taken as negative. So let's say, suppose if you have this state of stress condition, so can I represent this state of stress like this, in this form, yes or no? So obviously you can see this one is sigma y plane, yes or no, this is sigma y plane, and similarly this one is nothing but this is sigma x plane, yes or no. Let's say we assume this is x axis and this is y axis, yes or no. So with reference to this axis system, this plane will be taken as sigma x plane, and this plane will be taken as sigma y plane. And so now you can see here, in this system of loading, both stresses produces a clockwise couple. Both stresses are trying to produce a couple in clockwise direction, yes or no, or to rotate this element in the clockwise direction. So this shear stress, and actually this shear stress is nothing but this is tau by x, yes or no, stress acting on y plane and x direction, that's why it is written as tau by x. This is tau by x and this is tau xy, although both are equal in magnitude and opposite in direction, because both are complementary shear stresses, yes or no. So you can see in this case the stress acting on the sigma y plane is taken as positive shear stress, yes or no. So when the shear stress trying to produce a couple in clockwise direction, then it will be taken as positive. And similarly you can see in this case both stresses, you can see this is tau xy, yes or no. So tau xy is trying to produce a couple in anti-clockwise direction, that's why it will be taken as negative shear stress. So this is the sign convention which is used for solving for drawing Mohr circle, yes or no, under when the member is subjected to combined loading, yes or no. So before drawing Mohr circle, first you write assumptions used. Why? Because this assumptions is not universal, correct. If you see in the different book, you will get different sign convention, yes or no, correct. So this is not universal sign convention. So whenever we have this kind of things, so we need to write properly, yes or no, क्योंकि हमें एग्जामिनर को बताना है कि हमने कौन सा साइन कन्वेंशन फॉलो किया फॉर सॉल्विंग दैट क्वेश्चन. अदरवाइज साइन कन्वेंशन चेंज कर देंगे तो इट मे बी सोल्यूशन भी चेंज हो सकता है. इज इट क्लियर? So make sure while before drawing Mohr circle you should write sign convention, yes or no. After writing this, अब क्या करना है, you need to draw Mohr circle. So before drawing Mohr circle, let's say for the reference, here I am representing the given state of stress condition. This is sigma x which is equal to 100 megapascal, and similarly this is sigma y which will be taken as minus 50 megapascal, and similarly you can see here this is tau xy this is tau xy and this is tau xy. Although both stresses are complementary shear stresses and both are equal in magnitude, so don't need to write again and again. So this is tau xy, which is equal to 25 megapascal. Yes or no? So these are the stresses which are already given in the question. So what we need to do, first we need to represent reference axis system like this. This is a reference axis system. Along this we represent positive sigma and here we represent positive tau. Yes or no? This is tau axis and this is sigma axis. Means all normal stresses are represented along this axis and all shear stresses are represented along this axis. And obviously you can see here, this is nothing but this is origin. This is origin and its coordinate is nothing but this is 0, 0. Yes or no? And now you can see in the sigma x plane, you can see this plane is nothing but this is sigma x plane. Is it clear? This plane is also called as sigma x plane and this plane is also called as sigma y plane. Yes or no? So you can see in the sigma x plane we have sigma x axis whose magnitude is 100 megapascal. So here you can see, here I am drawing approximate Mohr circle because I am not taking scale. Yes or no? No need to take scale. Yes or no? Why? Because by using geometry we can easily determine the values. हम यहाँ पे कोई measure करके values find out नहीं कर रहे हैं. Yes or no? Because if you want exact value with the help of graph only, so you need to draw this figure in the graph paper only. Yes or no? तो यहाँ पे graph paper में तो हम कर रहे हैं, तो no need to write scale. Otherwise अगर आप लिखना चाहो तो you can do it. Correct? So let's say 100 megapascal is represented by this point. Is that clear? At this point. So can I say this is A prime and its coordinate is nothing but this is sigma x comma 0. But you can see in the sigma y, sigma x plane, along with sigma x we have tau xy. And what about tau xy? This is positive or negative? So obviously this will be a negative tau. It will be a negative tau. Yes or no? Why it is taken as negative? Because tau xy in both the planes will try to produce anticlockwise couple and it will be taken as negative. So here I am drawing up a line like this. Correct? So now here you can get the point. This is our final reference point. Is it clear? And this point is nothing but this is A and its coordinate is sigma x comma minus of tau xy. Yes or no? And similarly, can I represent a point B? So at a distance of minus 50, let's say this point is B prime and its coordinate is sigma y minus of sigma y comma 0. Yes or no? And obviously at the sigma y plane you can see again, in sigma y plane again you have tau xy. So we need to draw this line because magnitude of both the shear stresses are remain same. So simply we can represent like this. So you can see this point is nothing but this is called as B point and its coordinate is minus sigma y comma tau xy. Yes or no? So we can get B point as well as A point and these are the two end points of the Mohr circle. Yes or no? So simply now I can join these two points with the help of this line. So you can see here this line intersects the sigma axis at this point. So this point is called as center of the circle. This point is called as center of the circle. So now question is, what is the center coordinate of the circle? What is the center coordinate of the circle? So you can see in this slide, sorry, not in this slide. You can see I am writing here. So center coordinate of the Mohr circle, so you can see it is represented by this formula and irrespective of kind of loading. Yes or no? We always represent center coordinate with the help of this relation, and obviously you know sigma x, which is 100 megapascal, sigma y that is minus 50 megapascal over 2 comma 0. So simply here we can get 25 comma 0. This is the center coordinate, and similarly you can also determine radius of the Mohr circle. radius of the Mohr circle. How to determine radius of the Mohr circle? So obviously you know this relation. It can be written as sigma x minus sigma y by 2 whole square plus tau x y square. Yes or no? So how to put these values? Sigma x is nothing but this is 100 minus of 50 by 2 whole square plus 25 square. Now after solving this we can get 79, approximately 79 megapascal. Actually we get 79.054. So we just leave that point, that values we only took in 79 megapascal. So this is the radius of the Mohr circle. So you have center coordinate as well as you have radius of the Mohr circle. It means now we can and we also know the location of center. Yes or no? This is center. So can I draw a Mohr circle for this? Yes or no? And obviously this is center and its coordinate is nothing but this is 25 comma 0. Is it clear? The center coordinates are 25 comma 0. Is it clear? And similarly you can see here, this is sigma x plane, this is sigma x plane. When you join A point with center of the circle, then this gives us sigma x plane, and similarly when you join this center to B point, then it gives us sigma y plane. Yes or no? This is sigma x plane, and similarly this is nothing but this is sigma y plane. Yes or no? And from center to A point, this is radius of the Mohr circle, or center to this point is also called as radius of the Mohr circle. So once you get radius, center coordinates, center location, then we can draw the Mohr circle. Is it clear? So now let's see how to draw Mohr circle. Like this. So this is Mohr circle. This is your final Mohr circle. Is it clear? Correct? So I hope you will understand how to draw Mohr circle. And after drawing Mohr circle, how to solve this question? This is the main question. Yes or no? Correct? Why we use Mohr circle for solving this question? So you can see here, in this Mohr circle, if I represent tau max plane, so can I draw a perpendicular from this? So this gives us tau max plane. Yes or no? This is tau max plane, and let's say this is C, and can I represent this is D, this is E, and this is F point. Yes or no? This is F point. This is tau max plane, and CD is a sigma max plane. But now in this case, in this question, I am not interested for this. Correct? So what we need to do? First, you can see our first problem is to find out sigma max at a tau max plane. Sigma max at tau max plane means first we need to determine tau max plane. So you can see this is tau max plane. So the maximum normal stress corresponding to this plane is nothing but this stress. Yes or no? Can I represent this stress is sigma max? So the answer for this question is, you can see here, sigma max, the value of, you don't confuse with this sigma max. यहाँ पे आपको confuse करने की कोशिश करेगा कि sigma max पूछ रहा है किस प्लेन में, tau max प्लेन में. करेक्ट है? तो आपसे यहाँ पे कंफ्यूज करने की कोशिश करें कि आप सिग्मा मैक्स और टाउ मैक्स दोनों कैलकुलेट करके दे दो आंसर में, और वहीं पे आपका आंसर गलत हो जाएगा. करेक्ट? बिकॉज वी डोंट नीड टू फाइंड आउट सिग्मा मैक्स एंड टाउ मैक्स, दोनों ही नहीं चाहिए हमें क्या चाहिए कि टाउ मैक्स प्लेन में सिग्मा मैक्स क्या लग रहा है, टाउ मैक्स प्लेन में नॉर्मल स्ट्रेस क्या लग रही है. यस और नो? वी नीड टू डिटरमिन सिग्मा मैक्स एट टाउ मैक्स प्लेन. क्वेश्चन को ध्यान से समझो. इज इट क्लियर? वी नीड टू डिटरमिन सिग्मा मैक्स at a tau max plane. So इसकी वैल्यू क्या होगी? So you can see from the Mohr circle, this is tau max plane. So the normal stress is always represented along sigma axis and shear stress is always represented along the tau axis. So हमें क्या करना है, इस प्लेन के करस्पॉन्डिंग CF प्लेन के करस्पॉन्डिंग नॉर्मल स्ट्रेस पता करना है. तो कैन आई रिप्रेजेंट दिस नॉर्मल स्ट्रेस विद द हेल्प ऑफ दिस लाइन, यस और नो? करेक्ट. सो ओरिजिन से सेंटर की जो डिस्टेंस है दैट इज कॉल्ड एज सिग्मा एट टाउ मैक्स प्लेन, यस और नो? तो सिंपली हम कह सकते हैं फ्रॉम, यू जस्ट राइट फ्रॉम मोहर सर्कल, sigma max at tau max plane is nothing but this is OC distance and this is 25 megapascal. Yes or no? Simply आपको ये लिखना था and you will get the answer. But ये मिला कैसे? When you draw the Mohr circle. अगर आप Mohr circle नहीं ड्रॉ करोगे तो कोई वैल्यू नहीं मिलेगा. Yes or no? नेक्स्ट क्वेश्चन क्या कहता है कि what is the location of tau max plane? Yes or no? You also need to find out location of tau max. You can see the position of the plane on which they act. Is it clear? Means आपको यहाँ पे क्या find out करना है? You need to find out the location of tau max. And how to determine location of tau max? So then obviously you can see here this is your reference sigma x plane. So इस sigma x plane से इस plane की position पता करनी है. Yes or no? Correct. And let's say this angle is nothing but this is 2 theta s. So how to determine 2 theta s? Then obviously you see this is perpendicular to this. This angle is already known. But if you determine this angle and let's say this angle is 2 theta. Let's say this angle is 2 theta. So by using this angle, can I say 2 theta s is nothing but this is 90 plus 2 theta, yes or no? So my objective is to determine this 2 theta. Once we get 2 theta, then we can easily find out 2 theta s. And how to determine 2 theta? So simply you can say here we have a triangle. Let's say this is A prime, this is C and this is A. So we have a right angle triangle like this, yes or no? So by using this right angle triangle, can I determine tau max plane, yes or no? So simply you have this plane, yes or no? Correct. This is O, this is A prime, sorry this is not O, this is C, don't make mistake, this is C and this is A. And obviously what is the length of this CA? Obviously from O to C, you can see this is origin and this is center of the circle. So this distance is 25 and O से A के बीच का distance कितना है 100. So can I say this distance is nothing but this is 75 megapascal. And what about this distance? This is 25 megapascal, yes or no? And let's say this angle is 2 theta. This angle is 2 theta. So what about 2 theta? So can I apply tan 2 theta? Tan 2 theta is nothing but this is equal to perpendicular upon base and perpendicular is 25 and base is 75. So from this you can determine 2 theta, correct? And what about 2 theta? If I see 25 over 75 shift tan inverse this. So here we can get 18.434 degree, yes or no? And once you get this 2 theta, what we need to do? You can see this is tau max plane, yes or no? We have a figure like this. This is origin, this is center, this is A prime, yes or no? And this is A and this angle is 2 theta and this angle is 2 theta s, yes or no? And this is tau max plane, yes or no? Can I say? And you can see in this figure also from this Mohr circle I am drawing this figure, this and this one, yes or no? Correct. So from this can I say 2 theta s is nothing but this is 2 theta plus 90 degree, yes or no? So from theta s is equal to 1 by 2 times 2 theta s is nothing but this is 18.434 plus 90 degree. And when you simplify this, then you will get 54.2174 degree. So this is second part of first question. So we get 25 megapascal stress and the location of this stress is 54.2174 degree. So whenever you write theta, then you must be represented by only theta, not 2 theta. Yes or no? आपको theta से represent करना है, ना कि 2 theta से. Correct? So first part of this question is completed here. Now let's see another second part. The maximum shearing stress. What do you need to calculate? Maximum shear stress at a plane where the normal stress is 0. So you can see here where this plane is located. So from this figure, can I say, from this figure, can I say this is the point at which shear stress is 0. This is the only point at which normal stress is 0. Yes or no? This is the only point at which the normal stress is 0, that is origin. That is origin. Correct? And at 0 normal stress, you need to calculate shear stress. Yes or no? So actually you need to determine this distance. Let's say this is CG. But which in which plane this 0 normal stress act? So simply if I join this center of the Mohr circle to this G point, yes or no, then you will get this is the 0 shear stress plane. Yes or no? This is 0 shear stress plane. Yes or no? Correct? This yellow color plane is called as 0 shear stress plane, and we need to calculate 0 normal stress plane, and we need to calculate shear stress on that plane. Yes or no? Shear stress on that plane. Correct? So shear stress on that plane is nothing but you just project this point on the sigma axis, then you will get the normal stress, and if you project this point on the shear stress plane, the shear stress axis, then you will get the tau max. Yes or no? So can I say from origin to this point, this distance is nothing but this is called as tau max. Yes or no? At 0 shear stress plane. So if I remove this triangle, if I remove this triangle from the figure, then what we will do, you can say this is part 2. So simply can I represent like it is looking like this? Yes or no? You can say this is origin, this is center, this is A prime, and this is A. Its coordinate is 100 comma minus 25. Its coordinate is 100 comma 0. Yes or no? Center coordinate is 25 comma 0, and origin coordinates are 0 comma 0. Yes or no? Correct? This is tau max plane. This is tau max plane. Yes or no? And this plane is 0 normal stress plane. And this point is G and this point is F. Yes or no? Correct? So you need to calculate, here you need to calculate OG length, and this OG is nothing but this is tau max at 0 normal stress plane. Yes or no? Correct? So how to calculate this length? This is our objective. So can I say this GC is nothing but this is radius of the Mohr circle, because from center if you join any point on the circumference from the center of the circle, then that one gives us radius of the circle. Yes or no? So this is radius, and this distance is already given here. OC distance is nothing but this is 25, radius is